All right, we're back with our client-server remote procedure call shenanigans here. We've got the ability now to parse our standard input, sending commands to the client, the child process, who is going to initiate operations. Nice. But right now we've only got one kind of operation, or one kind of command. That's the move command. And those are rookie numbers. We got to pump those numbers up. So let's create a new kind of command, and we're going to send a string, and the child process must then set that as the title of its window. It'll be a fun little second command for us. Now there's a lot of things that we gotta splice out here. So first of all, what's this struct for the command gonna look like? The title command. Well, we got some options here. Could do std string. And that's obviously, very convenient and very powerful. However, it does kind of preclude our modus operandum up until now of just taking the size of the structure and size of structure here and just like firing out the bytes. Because obviously std string is a little bit of a different beast. It's got its data in a different place than where the actual object is going to be living in this struct. So things ain't going to be so simple. You're going to have to do a little more finagling. The other option is, of course, you could do like a char array, char array, whatever you want to call it. And in this case, well, you've got to basically hard code in here a size. And if the size is too small, then you're going to be out of luck when someone wants to do a bigger title. And if the size is, really big, you're going to be wasting a lot of bytes being sent over the network for no good reason. So I think we got to do std string. We got to do std string. We want to be shitty. You could do like just a static buffer. In many cases, it's fine. But it is not going to be the best solution, especially if you want to optimize your network performance, which in many scenarios is something that you'd like to do. Okay, so we've defined our structure. We've got our two structures for our two different commands. Now, when we send this data, when we send this stream of bytes inside of a packet to the other guy, how does he know whether he's getting a move command or he's getting a title command? That information is going to really determine how he's going to deserialize that data, which structure he's going to spit out. So let's add another struct, and we'll call this one the header. Now the header is going to, let's do std string. It's going to give us some useful information. Std int. Okay. So first of all, we'll do 32-bit unsigned integer, and that'll be our size. So this is going to tell us how big the payload is, the part that comes after the header. So let's call this one the payload size. And we also are going to want, and I guess we're going to make a new thing here, enum class command type. So we got two kinds of commands. We got the move and we got the title command. And so here we're going to put in command type. All right. So every time we send data, it's going to have at the very beginning, it's always going to have this header. And then after those headers, it's either going to have the bytes for the move command or the bytes for the title command. And we inspect the header first to determine which one it is and use that information to determine how to deserialize the data, how to take the bytes and stuff them into the appropriate command and spit that out. Now, there's another problem. The iClient spits out a vector of, well, right now it spits out a vector of move commands. Very convenient that it was only a single type of command. Now we have two types of commands. So what does it spit out? It can't be one or the other. That's very inconvenient. We got two options. We can make these commands virtual, and then we can put in here a vector of, unique pointers to the commands and use the virtual interface or what have you. That is not really great for our situation. I don't think that's a good fit, especially for what I have coming up in store, the really good stuff. This is still the setup. You gotta understand, but it's not great to do it virtually. So the other thing you could do is statically, and you do that with a union. And the nice way of working with unions is std variant. So let's do a little variation with our variant. And so we're going to do using command is equal to std variant, and you template it on all the different what is it called, alternatives that are possible. So we have two alternatives. We have move command and we have title command. So these are the two kinds of things that can be. A command can either be a move command or a title command. And that is dynamically stored at runtime. And when we can make a vector of commands, and that will be fine. Now, in send command, we can't send just a move command. So what we're going to do here is we're going to change the signature here, and we're going to make it take a span. So we'll make this bad boy take in a span of bytes. So the virtual send is only going to work with the dirty bytes, and we're going to have to make a templated function to work with the good stuff. So where is your boy? Here it is. Now we can filter out a little bit of more noise here if we do another boy. I would do a little boy. Boy. My brain's not working right now. Sorry, I'm fried. Command type. So this one will take in the type, and then it'll take in the bytes. I'm gonna propagate that back here. It's a work in progress. All right. Now we need to send. Ideally, we want to do this in a single send. We don't want to send 2 packets. You know what? Screw it. Let's just do it the dirty way. Spoilers. This code is not sticking around. So we could try to get the header and then the payload bytes into a single buffer and then send that all in one swoop. But we're gonna just send twice because we're lazy. So we're gonna set up our header. It's gonna have payload size is equal to command bytes dot size bytes. There you go. It's not gonna like that because this one's probably like a size T. So we'll do like a uint32t boy in there, and then the other one is the dot type, which is equal to type. There we go. So there's our header, and we're just gonna send that bad boy right out there. AS buffer and HDR. I was gonna check to see if I actually need to do the reinterpret cast. We could just do size of HDR. Yeah, that's the buffer. Fine. All right, so there's the header, and then we gotta send the actual payload, which is just going to be socket.send again. Use buffer to, no, that's not what I wanted. Just wrap up our command bytes. I think we can just send it like this. There you go. So that's fine. It's not great, but it's going to get the job done. Maybe. We'll see once I compile it. So there's the thing that sends the bytes, but this is not what we want to do. So let's add another thing. We'll go template class T for our command type, void. Send command. What do we want it to be? Let's just do const T. And because it is a template, we can't put it in the other. We got to keep it in here. But as long as it only calls this function, it's fine. We're not going to leak anything from ACO, hopefully. So let's do some mild template compile time shenanigans. Let's include. We might not need it, but let's include concepts. I do like my concepts. Std. Same as. So we're just going to go through the options. So if T is the same as move command, then we need to set us up the bomb. So this is going to be send command. The type is going to be command type move. And then the bytes are going to be command dot title. Else, I mean, we don't need an else. Let's just do if const expr std. Let me just copy paste. Copy pasta never caused any problems in the past, has it? Certainly not. Title command. Well, I see a little problem here. This is the title. I implemented the title command, and now the move command is a different beast. So this is going to be, let's see if I get this right here. Std span I'm thinking we do need to like reinterpret cast here. Std, no, just a reinterpret cast. Yeah, const char pointer ampersand command size of command. There we go. It's just a mem copy situation. And in the case of title command, we're going to take the data of the title container. That's going to make the span. So this feels to me in my feels like it's going to work. But truth be told, I have very little confidence that this is going to compile out of the gate. That's fine. Now we do the other half of the thing, which is the receiving. All right, so in here. So we got to receive, what do we got to receive? We do async read. Let's read into a header. So step 1, read into the header. Step 2, if your boy header dot type is equal to, so if that there is a move command, we'll just make like a command. So that's a move command. Then we want to do something like cmd dot. Okay, let's see here. In place. Maybe in place is like templated. Maybe we could do something like move command, like this. What about, how do you like me now? Yeah. So we're saying, okay, now your boy's holding a move command. And then we just got to like read into there. So how do we do that? We need to get like a reference to the move command, which is inside this variant, because there might be other stuff in there. We can't just take the address of the variant. So how do we do that? We do like std get move command from our command. We get a pointer to the move command. So this is saying if this variant holds a move command, give me a pointer to the move command. But if it don't hold a move command, we're going to get a null pointer. Now it's got to hold a move command because we just in placed a move command here, so it is guaranteed. But normally you want to check that shit. And the compiler might actually scream at me that, hey, this thing could return null pointer, you dumbass. But that's okay. Now, the size of bytes that we want to get, we could do this 2 different ways. We could do size of move command, get that shit at compile time. But we could also do header dot payload size. We're going to use it this way. So we read that into there. Then at the end, receive commands. That's what I was looking for. Receive commands dot pushback std move cmd. It's a little angry. Probably because this should be command, not move command. You should also return command. All right, much happier. Else if command type is equal to title, and place the title command. Do we really need to do this hanky panky? Like, do we need this here? No. Do we? Like, what if we get rid of this? We just do like move command cmd. Then I could just do like and cmd, and then size of cmd. That's nicer. And then we just add a little line here. We just say, hey, received commands pushback std move cmd. And so that's going to construct a variant of type move command, and then Bob's joke. I like this better. I like this better. All right, let's do the same for here. Title command. Now we got to be careful. Okay, so we can't just like copy into the structure because that's not how this works. So we got a title command. Title command is going to have a string in it. So let's do cmd.title.resize, because we know the size that's in the header, dot payload size. Okay, so we know that because we implemented the serialization function. Now in the deserialization, we just got to match it. So we resize that. Now we can read into command.title.data, and then header dot payload size. So we read into the title. Now we have a title command with the title properly populated. So we can do this pushback std move is very nice because this has a string in it. And move the command into the received commands. And this doesn't make any sense. And there you go. And now if it's something else, if it's not anything that we expected, that's a problem. Throw std runtime error. All right. I'm liking it. I'm liking it. Now because we're spitting out variants here, so send command takes in templated command type. So I think This one just works fine. It's completely happy with that. But this one is not so happy. Yeah, it's got a variant coming out somewhere. If it's unhappy, it's not showing it, but I think it is unhappy. So we gotta, in here, we gotta check like what kind of variant do we got here. So if auto p move is equal to std get if net move command. So if we got a move command on our hands, what's your problem? You want to probably do like this and like that. Yeah, perfect. Then we want to emplace back operation pointer to p move. There we go. Else if std get if net title command. What do we do here? Well, we got to change the title of the window. So simp win set title. Now here's a problem. This thing takes a wide string. Our commands are doing narrow strings. All right. Namespace somewhere. Too wide. Beautiful. P. Ugh. We don't want to call this one P move. We want to call this one P. Tit. Beautiful. Okay. So now we got it working on the sending side, working on the receiving side, but we got one little piece of the puzzle. We gotta actually parse the command line. We're only really handling exit or other thing here. What we should do here, by the way, is we should destroy the child before we exit this scope, because we want to destroy it before we destroy the socket connection. Otherwise, it's ACO is going to throw a bunch of exceptions. It's kind of nasty. So we should do p child pointer to terminate, and then we should exit. All right, so we're handling exit. Now we need to, when we get line, we're going to have to give each command its own name so that we can differentiate them. Because right now there's only really one command, but we want at least another one. So how do we do that? All right, so what we want to do is for every line, we want to split it into command name and then argument string. And then the argument string will be processed like this later on, but we'll have the command name to switch on or if else on. So that's going to look a little bit like this. So we're going to split. So we got maybe some white space. Then we got one capture group. That's the command name. Then maybe some more white space. And then we got another capture group, and that's going to be your boy. The argument string, we'll just print out a little error, and then we'll let you try again. Now, if it does match, then we get a command and an arg string. And if that command is equal to exit, then we want to break. Else, if it's equal to move, then we want to do this stuff in here. So we'll change the error code here, error message, a little better one. But yeah, if the command is move, then we're going to parse the argument string like this and do as we did before. But else if command is equal to tit, well, then we want to send the title, and that's just like that. And that's nothing more to it. Now if we don't, if anything else, we don't know what the hell that is, so we can just do like unknown command. There you go. All right, so there's the parsing. All right, now the moment of truth. Try to build this monstrosity. Okay, string is not a member of std. Easy enough to solve that problem. Oh, that wasn't so bad. It was just a little. It was missing a little include boy. All right. Now, of course, the question is, does it actually work? Oh, this. All right, that definitely didn't work. Okay, let's try the other one just for sharts and gaggles. Do like a 0, 0 to 100, 100. Okay, nothing works. Shit's broken, like just all around. Does this work? Well, that works. Okay, one thing works. Okay, so we hit the breakpoint, which means the client is getting something. It's going into command move. Okay, so that's a small problem. Let's look at what the header looks like. Payload size 3. That's just it's all kind of like, there's no way it could be a 3, right? That doesn't make any sense. Okay, well, I see a first problem here. Remember when I said that copy and paste never steered us wrong? Okay. So there's one thing, but I'm still not very optimistic. Looking at the size that I got in there, I'm thinking we're gonna have problems. Okay, where are we going? Yeah, we're going here first. That's expected. Type is now gonna be title. Command bytes is size 3. Why? Okay, so that's like the name of the command. TIT. That's wrong. But we're getting closer. Probably a parsing error. Probably the parser put the wrong damn thing in the title command. Title is equal to match 1. That doesn't make any sense. We didn't do a thing. It should be the arg string. Std move arg string. We just put the arg string like right in there. Okay, so we're getting to the bottom of this. You see, there's multiple layers to this. We can screw up parsing. We can screw up serializing. We can screw up deserializing. We can screw up. There's all sorts of options for screwing up. Hello, you stinky dog. Ah, okay, we're hitting our breakpoint. That's fine. Go. The hell we go. So we have a command, and the command is not shitting the bed. Not shitting the bed. Yeah, there we go. What if it's just like an empty thing? It works too, which is fine, because that's what it's meant to do that. Oh, beautiful, beautiful. Okay. No, that's not the command. There you go. All right. So title is working. Now move is not working, but it was a parsing error. That was a problem with the parsing. Ah, it makes sense because we're matching the line. The line now contains the other stuff. What we want to be matching is the arg string. Yas queen. That makes sense. All right. So now I should be able to do the movie and the titty. 400, 400. I don't know. Let's go. Hey, it's doing something. He's not wrong. We can send multiple of these bad boys. Aha. Oh, that's working. All right, so we have now successfully added a second command to the roster. Things have gotten a little more complicated, but that's to be expected when you can't have a system like this and expect to only have one kind of command you're going to send. Not very likely. So now we can support multiple command types. And we're looking at, we got some structures that contain, it's not just a trivial plain old data structure now. It's got some layers to it. So we have to handle now these structures on a per structure basis. This one, we can just mem copy that bastard out there. This one we gotta be a little more sophisticated.